So the last section we've done in this unit was all about the cell and energy, how the cell uses food to make energy or how the cell uses energy to make food. Both of these, this next section has to do with moving cellular materials in and out of the cell membrane. Both of these sections have to do with a process the cell goes through that helps the organism stay alive, but this one's kind of shifting gears and is quite a bit different. So there's two general ways in which cells get things or get materials in and out of the cell. They are passive and active transport. Passive transport is the movement of materials through the cell membrane without using energy. And you can kind of use the clue word passive to help you remember that definition. Again, transport has to do with transportation, moving materials. Passive typically means not being active, sitting back and letting things happen, being more sedentary. So it would make sense that passive does not use energy, and transport has to do with materials going through the cell membrane, transporting through the cell membrane. Active transport, on the other hand, is the opposite. It's the movement of materials through the cell membrane with using energy. And again, transportation, movement of materials through the membrane. Active, using exercise, moving a lot, doing a lot of things at once. You have to use energy for that. So really know the clue words and you can define these words. The two ways cells move things through the membrane. So now we're going to get more specific. Last slide I said these are two general ways cells move things in and out of the membrane. Now we're getting more specific. And looking at just passive transport, there are three different ways in which cells move things through the membrane without using energy. Those ways are diffusion, osmosis, and facilitated diffusion. And all three of these have something to do with diffusion. Osmosis is the diffusion of water. So that's one way to remember the three types of passive transport. All three have to do with diffusion. So starting with just diffusion to get a basic understanding of what diffusion is. Its definition is right here. Molecules move from an area of higher concentration to an area of lower concentration until equilibrium is reached. And it's important to note that a high concentration means that there's a lot of stuff in a very small area. And a low concentration means the stuff is more spread out in that area. And I like to think of a perfume example. When you first spray a perfume, the scent or the amount of molecules of perfume or droplets of perfume are very strong. Because when you first spray it, it's all in one area. And eventually those little droplets of perfume spread out throughout the room, and sometimes you can even smell the perfume in the entire room after you spray it. And that is diffusion. They started out in a very highly concentrated space, and they slowly moved to lower concentration until they were equally spaced out. And here I say until equilibrium. Equilibrium has a base there, equal, although it's spelled a little differently than you're used to. That's important. Equilibrium, equally spaced apart. Here are two examples of diffusion. Here's one where it's a very high concentration and slowly it's moving to a lower concentration. In this example would be this line, pretend it's the cell membrane. And let's say we take in oxygen. Each one of these yellow dots represents an oxygen molecule. Outside the cell, it's very highly concentrated, and they're slowly diffusing into an area of lower concentration, which is inside the cell. We need oxygen to stay alive. Here's kind of my perfume example, that when you first spray the perfume, it's in a very highly concentrated area, and it slowly spreads out to these areas of low concentration until equilibrium is reached. So right here is an example of equilibrium. The actual definition of equilibrium is right here. I'm going to put a box around the word, the circle. I said I was going to put a box around the word equilibrium. Oh my goodness. Where's my rectangle? A box around the word equal to help you remember it has to do with molecules being equally spaced apart. And to understand diffusion, you really have to understand concentrations. So a concentration is the amount of substance in a given volume. And you calculate it by taking the mass of the solute divided by the volume of the solvent. Mass, remember we learned our units, mass is measured in grams, volume is measured in liters. To understand solute, that's the substance that is being dissolved, and solvent is what the substance is being dissolved in. Think of when you're mixing salt water. The solute would be the salt. You're putting a teaspoon of salt into hot water. That is what's going to be dissolved. The solvent would be the hot water because that's what the salt will be dissolved in. So the solvent's always going to be a volume. The solute will usually be a gram. Here's an example of how to calculate concentration. You do have to know, this is one of the few math concepts you learn in biology, but you have to know how to calculate a concentration. So you dissolve 5 grams of sugar in 1 liter of water. What is the sugar solution's concentration? So we take the mass of the solvent divided by the volume of the solute. In this case, our mass is 5 grams, and we're going to divide it by the volume, which is 1 liter. And 5 divided by 1 equals 5, and we have to put units, grams over liters. So that's how you do it. You just take the one that has the grams, the solvent, and divide it by the solute. And our last slide for homework is titled What Causes Diffusion? And again, we're going to get into a little chemistry here, but in general, to say something's at rest is not actually true. When you go down to the atomic level of anything, its atoms, its molecules, its compounds are constantly moving. Even though we can't physically see it, everything is either moving or vibrating in some way. So diffusion in our bodies, let's use the oxygen example, has to do with molecules. Because they're moving, they bump into each other. And think about it, when you're in a line and somebody bumps into you, you naturally are pushed away from that person until you bump into another person, and then that person's pushed away from you, and so on. So diffusion is caused by these molecules bumping into each other. Remember, if you have a very high concentration of molecules, and they're constantly moving, eventually they're going to start spreading out until equilibrium's reached. Because they bumped into each other. They're like, I don't want to be near you anymore. So that is why diffusion happens. And we're going to stop there. There's 2 more pages of notes on diffusion, but I don't want to kill you for homework. So you guys all have a great night.